We are again given 4 sets, each set containing 2 species. We are asked to compare the strength of acids in each case. An acid is one that gives out a proton and forms an anion. So in each case, we have to consider the anion formed by the loss of the relevant proton. In the first set, we have CH2Cn twice forming the anion, which can be represented by 3 canonical structures. In one, we have the negative charge resting on carbon, and in the other 2, the negative charge resting on the 2 nitrogens respectively. For the second species, we have one structure with the charge on carbon and a second structure with the negative charge on oxygen. There is a greater degree of delocalization in the former case because there are 3 canonical structures and there are 2 structures involving the more electronegative nitrogen taking the charge. And therefore, this conjugate base is weaker because of greater degree of delocalization and greater stability. This becomes a weaker base, and therefore this acid is stronger. In the second, we are given a ketone and propene. We are able to write resonance structures in both cases. In the case of the ketone, one structure has charge resting on carbon and the other structure has charge resting on oxygen. The more electronegative, oxygen takes the charge. There are 2 possible canonical structures for the anion obtained from propene also. But in this case, the negative charge is delocalized on the very weakly electronegative carbon. If oxygen is involved, it being more electronegative, the stabilization is greater. And therefore, the conjugate base of acetone is weaker. And therefore, the ketone is more acidic than the hydrocarbon. In the next, we are given CH2, Cn twice, and we are also given ethylene dicyanide. In the case of ethylene dicyanide, we are able to draw only 2 structures with the negative charge resting on carbon or on nitrogen. We have already seen in the case of CH2Cn twice, there are 3 possible resonance structures for the anion with the charge delocalized on the electronegative nitrogen atoms, making this anion more stable. And therefore, the acid CH2Cn twice is stronger than the other. In the fourth, we are given 2 enols. Both are propenols. One is propenol 1. The other is prop2-en-1-ol. In one case, the OH is attached to sp2 hybrid carbon. In the other, the OH is attached to sp3 hybrid carbon. sp2 hybridized carbon is more electronegative, would be able to stabilize the anion better, and therefore the corresponding anion is a weaker conjugate base, and therefore the parent compound becomes more strongly acidic.